Kennedy Space Center, Florida, the morning of January 28, 1986. On Launch Complex 39 billion, Space Shuttle Challenger stands fueled and connected to 7 crew members. The mission number is STS-51-L. The mission is the 25th flight of the Space Shuttle program and the 10th flight of the Challenger orbiter. The crew boarded at 7:30 in the morning. Commander Francis Scobie, pilot Michael Smith, mission specialists Ellison Onizuka, Judith Resnick, and Ronald McNair, payload specialist Gregory Jarvis, and teacher in space participant Sharon Krista McAuliffe. The ambient air temperature on the pad is 36 degrees Fahrenheit, that is 2 degrees Celsius. It is the coldest launch in the history of the Space Shuttle program. The crew does not know what happened the night before at a teleconference between Kennedy, Marshall Space Flight Center, and Morton Thiokol, the contractor that builds the solid rocket boosters. The engineers who designed the seal at the base of each booster did not want to launch. They have been overruled. The countdown clock, held at T-9 minutes, is about to resume. At 5:38 a.m. Eastern, the ice inspection team reports significant ice on the pad service structure, on the water suppression troughs, and on the mobile launcher platform. The inspection is the first of 3 that morning. The previous night at 8:45 p.m. Eastern, a teleconference between Kennedy Space Center, Marshall Space Flight Center, and Morton Thiokol at Wasatch, Utah, opens. Thiokol engineer Roger Boisgelly presents data on the O-ring field joints at low temperature. The O-rings are rubber seals. They keep hot propellant gas from escaping at the joints where the booster segments connect. Boisgelly's position, entered into the Rogers Commission record, is that the O-rings have no demonstrated performance below 53 degrees Fahrenheit. The pad forecast is in the 20s overnight, rising to the 30s at launch. At approximately 10:30 p.m. Eastern, Morton Thiokol management, after an offline caucus, reverses the engineering recommendation. Vice President Joe Kilminster signs the launch rationale memo. Thiokol engineer Alan McDonald, present at Kennedy, refuses to sign. His statement is in the commission transcript, "I would not sign it." At the pad at 11:15 a.m., the ICE team completes the third and final inspection. Surface readings on the right solid rocket booster's aft field joint, taken with infrared, read as low as 28 degrees Fahrenheit. At 11:25 a.m., Launch Director Gene Thomas on the operations loop confirms. The count is proceeding. At T-31 seconds, the onboard computers take control of the countdown. At T-6.6 seconds, the 3 Space Shuttle main engines ignite in staggered sequence. Chamber pressure builds, the vehicle twangs forward, then settles back to vertical. The solid rocket boosters cannot be shut down once lit. At T-0, the solid rocket booster ignition command is issued. At T+0.01 seconds, the solid rocket boosters ignite. Chamber pressure climbs toward 913 pounds per square inch. At T+0.678 seconds, the hold-down bolts release. Challenger lifts. In that same frame, T+0.678 seconds, tracking camera MNS-60, fixed on the base of the vehicle, records a puff of gray smoke emerging from the aft field joint of the right solid rocket booster. The plume appears at the 305-degree azimuth. It is documented in the Rogers Commission Photo Analysis Annex as the first visible sign of the seal failure. At this instant, the flight crew still does not know. Mission Control does not know, the camera knows. At T+2.273 seconds, the tracking cameras record 8 distinct puffs of dark smoke from the same joint. The smoke is dark, indicating burned O-ring material and the putty used to line the joint. At T+3.375 seconds, the last visible puff registers, then the smoke stops. Aluminum oxide slag from the propellant has temporarily plugged the breach. At T+7 seconds, the onboard guidance computer commands the program pitch maneuver. The vehicle rolls, heading downrange toward a 28.5-degree orbital inclination. The roll program is nominal. At T+19 seconds, the 3 Space Shuttle main engines throttle down from 104% to 65%. This is the planned throttle bucket for passage through the region of maximum dynamic pressure. The CAPCOM in Houston is astronaut Richard Covey. His voice is calm on the air-to-ground loop. The cockpit voice recorder on the orbiter, separate from the mission control loop, also runs. At T+28 seconds, Challenger passes through Mach 1. At T+35 seconds, telemetry registers the first of several strong wind shears. The vehicle encounters wind velocity changes greater than any previously flown by a space shuttle. The flight computer adjusts engine gimballing and booster nozzle vectoring to correct. At T+36 seconds, the vehicle reaches maximum dynamic pressure. Instruments record 720 pounds per square foot on the windward surface. The vehicle is at roughly 22,000 feet altitude, traveling at approximately Mach 1.5. At T plus 37 seconds, a second wind shear layer is encountered. The booster nozzle actuators again respond. At the aft field joint of the right booster, the aluminum oxide slag plug, which has been holding the breech sealed since T plus 3.375, begins to shift under the combined stress of vibration and dynamic pressure. At T plus 51.86 seconds, with the vehicle now through max Q, the onboard computers command the three main engines to throttle up from 65 to 104%. This is the nominal throttle up sequence. On the air-to-ground loop, CAPCOM Richard Covey keys the microphone. The transcript reads, "Challenger, go at throttle up." At T plus 52.17 seconds, Commander Francis Scobie responds. His transmission is recorded by the operational recorder. The transcript reads, "Roger, go at throttle up." These are Scobie's last words to mission control. At this point, the flight crew still does not know. Everything in the cockpit reads nominal. The chamber pressures on all three main engines hold. The booster chamber pressures hold. The guidance and navigation indicators hold. But at the base of the right booster, the plug is failing. At T plus 58.788 seconds, tracking camera Eminus 207 records a first visible flame plume at the aft field joint of the right solid rocket booster. The plume is small. It is triangular. It is directed aft and outboard. The Rogers Commission later describes it as an abnormal plume. At T plus 59.262 seconds, the plume grows. It reaches across the gap between the booster and the external fuel tank. The flame is now visible on the side of the external tank facing away from the orbiter. At T plus 60.004 seconds, the plume is deflected by the aft strut that attaches the right solid rocket booster to the external tank. The deflection aims the flame directly at the side of the external tank's liquid hydrogen section. The external tank, in its aft section, contains liquid hydrogen at minus 423 degrees Fahrenheit. The tank wall is aluminum, fractions of an inch thick. At T plus 64.66 seconds, the flame pattern on the tracking cameras changes abruptly. The shape widens and brightens. The Rogers Commission concludes this indicates a breach in the aft dome of the liquid hydrogen tank. At T plus 66.764 seconds, the telemetered liquid hydrogen ullage pressure begins to drop. Liquid hydrogen is escaping. The onboard computers register the anomaly but hold course. On the cockpit voice recorder, the crew's intercom is running. The recorder is an analog device mounted in the crew module. The Rogers Commission makes the transcript public after recovery. At T plus 68 seconds, cabin intercom captures ordinary crew communication, confirmations of engine performance, no alarm. At this point, the flight crew still does not know. At T plus 72.204 seconds, the final telemetered liquid hydrogen ullage pressure reads 19 pounds per square inch. The liquid oxygen tank pressure still reads nominal. At T plus 72.284 seconds, tracking cameras record white vapors near the intertank region of the external tank. The liquid oxygen tank forward of the intertank has now begun to fail at its attachment. At T plus 73.124 seconds, Commander Scobie's transmission on the air-to-ground loop, "Roger, go at throttle up," which began at T plus 52.17, is acoustically complete. The voice is the last one mission control hears from Challenger. At T plus 73.191 seconds, the cabin voice recorder captures a transmission from pilot Michael Smith. The recorded word is, "Oh, this is the last audible voice captured by the crew cabin recorder." At T plus 73.213 seconds, the liquid oxygen tank collapses forward onto the intertank and then onto the liquid hydrogen tank. The tank structure fails. The external tank vents catastrophically. At T plus 73.618 seconds, the last valid telemetry signal from Challenger reaches mission control. The orbiter, no longer supported by the external tank, rotates into the slipstream and breaks apart under aerodynamic load at 46,000 feet, Mach 1.92, dynamic pressure 720 pounds per square foot. At T plus 76.437 seconds, the range safety officer at Cape Canaveral transmits the command to destroy the two solid rocket boosters, which have departed the stack and are flying uncontrolled. In the mission control room, the first indication of a problem is silence on the data. Flight Dynamics reports loss of telemetry. At T plus 110 seconds, the crew cabin, intact as a pressure vessel, reaches apogee at approximately 65,000 feet. It then begins a ballistic descent. At approximately T+245, the crew cabin strikes the Atlantic Ocean at about 207 miles per hour. The Kerwin Report, released in 1986, documents that the cabin was found and that certain personal egress air packs had been activated. The public affairs officer in Mission Control is Steve Nesbitt. On the air-to-ground loop, his voice is steady. The transcript reads, "Flight controllers here looking very carefully at the situation. Obviously a major malfunction." A further transmission minutes later. "We have a report from the flight dynamics officer that the vehicle has exploded." The range safety debris cordon closes the ocean area. The Navy, the Air Force, and NASA begin a recovery operation that lasts months. On February 3, 1986, President Ronald Reagan appoints the Presidential Commission on the Space Shuttle Challenger accident. William Rogers chairs. Neil Armstrong serves as vice chair. The commission convenes formally on February 6. On March 8, 1986, the salvage ship USS Preserver locates the crew cabin in approximately 100 feet of water off the Florida coast. Recovery operations continue through April. On June 6, 1986, the Rogers Commission issues its final report. The commission finds that the cause of the accident was a failure of the pressure seal in the aft field joint of the right solid rocket motor. Contributing causes include flaws in the decision-making process. The Space Shuttle program returns to flight on September 29, 1988 with STS-26 Discovery. That was the final 73 seconds of Challenger STS-51-L 73 seconds reconstructed. Every timestamp sourced, every transmission reel, terminal hour, educational content. Based entirely on public inquiry reports, air-to-ground and cockpit recordings, sworn testimony before the Rogers Commission, and the documented investigative record. Next week, 2:20 in the morning, North Atlantic. A ship made of iron is about to meet an iceberg.